The first month I ran AI seriously, the bill surprised me. Not in a catastrophic way, but enough that I had to sit down and actually understand what I was paying for. I had been treating API calls like they were basically free, just a small fee per request that I could mostly ignore. And the thing is, for light use, you probably can, but the moment you start building anything real, running things in loops, doing batch work, keeping long conversations going, the math changes fast. So I went digging into exactly where the money was going, and what I found was not one big leak. It was a handful of small habits that stacked quietly. This video is about the specific things I changed so that the bill stopped surprising me, and the principles behind them that I now apply to every AI task I build, where token costs actually come from. Before you can control costs, you need to understand what you are actually paying for. The unit is a token, which is roughly 4 characters of text, and the billing model for most large language model APIs is simple. You pay for tokens in, and you pay for tokens out. Input is what you send to the model, the system prompt, the conversation history, any documents or context you attach. Output is what comes back. On almost every provider I have used, output tokens cost more than input tokens, sometimes 2 to 5 times more. So a model that writes a lot is more expensive than one that answers briefly. Everything else equal. Now here is the thing that catches people. The price per token goes up on larger, smarter models. A model that is 4 times as capable might cost 10 times as much per token. And context length amplifies everything. If you have a 10,000 token context window and you make 20 calls, you are paying for that 10,000 tokens 20 times over. Not once, every call. Retries and loops quietly multiply your bill. The sneaky cost driver that bit me hardest early on was not a single expensive call. It was calls that happened more often than I expected. A retry loop that ran 6 times instead of 1. An agent that went back and forth with itself 5 more steps than needed. A script that caught an error and just quietly started over from the beginning. Each individual call looked fine. The total looked very different. This is especially dangerous with agentic code, where the model is calling itself or other models in a chain. One runaway loop in a pipeline I left running overnight once cost me more than a full week of normal usage. The loop was doing real work on each step. It just never found a stop condition, so it kept going. I did not notice until the next morning. That experience changed how I instrument everything I build. Match the model size to the task. The first tactic that actually moved the needle was also the simplest. I stopped using the biggest, most capable model for every job. I had been defaulting to the strongest model available for everything, which felt safe, like I was guaranteed good results. But a lot of what I was doing did not need that. Summarizing a short document, extracting a field from structured text, classifying an input into one of 5 categories. These are tasks where a smaller, cheaper model does just as well. I ran some tests on structured extraction jobs. The smaller model got it right just as often as the bigger one, and cost a fraction of the price. Now I have a rough mental tier list. Simple classification and extraction gets the small model. Drafting that needs real judgment gets the mid-tier. The hardest creative or reasoning tasks get the full model. I am not prescriptive about which tools I name, because the tiers change constantly as new models come out. But the habit of asking which size this task actually needs is the first question I run through every time. Check how much context you send. The second tactic is about context management, which is where a huge amount of waste hides if you are not paying attention. Context is the full input you send to the model on each call. The conversation history, the documents, the instructions, and the pricing model means that if you keep adding to it, you pay for all of it on every single call. I have seen setups where someone builds a chatbot with a long document retrieval system, and by the middle of the conversation, the context is 20,000 tokens of history that neither the model nor the user really needs. Every response adds to the pile, and every subsequent call pays for the whole pile. The fix is ruthlessly trimming what you send. For conversation history, I keep a rolling window, not the full unbounded log. For documents, I retrieve only the relevant chunks using a search step rather than dumping the entire document. For instructions, I keep the system prompt tight and review it every few weeks to cut what has drifted in. None of these changes hurt quality in practice. The model does not need your whole conversation history from last Tuesday to answer a question about today. Teach repeated work. The third tactic is caching, and it is one of the highest leverage moves if your workload has any repetition. Most API providers now offer some form of prompt caching, where if you send the same prefix repeatedly, you get a significant discount on those cached tokens. The idea is that if you have a large system prompt that you send on every call, and it does not change, you should not be paying full price for it every time. In my setup, I have a few workflows that run the same large context prefix hundreds of times a day. Switching to cached prompts on those cut the input cost on that portion to a small fraction of what it was. The tricky part is that caching only works for content that is genuinely identical across calls. If you are dynamically inserting different user data into the middle of your system prompt, the cache breaks and you lose the benefit. Structure your prompts so the stable parts come first and the dynamic parts come at the end. That one layout change made a real difference to my cache hit rate. Batch jobs where you can. The fourth tactic is batching. A lot of API providers offer a batch mode where you submit a large number of requests together and they are processed with a delay, usually a few hours, in exchange for a lower per token price. The discount is meaningful, typically around half the normal rate. The catch is that you do not get the results back immediately. For real-time work, synchronous jobs, user-facing responses, batching is not an option. But for anything that runs in the background and does not need an immediate answer, it almost always makes sense to batch it. In my pipelines, I split jobs into two lanes early. Anything that needs to respond in seconds stays synchronous. Anything that can wait, analysis, classification, bulk content generation, goes into the batch queue. The cost difference adds up fast when you are doing hundreds or thousands of calls a day. Offload cheap bulk work to a local model. The fifth tactic is running a local model for the work that does not need a hosted service. I have a machine with a graphics card, and I run a smaller open source model on it for tasks where quality requirements are modest. Things like generating rough outlines, doing basic text cleanup, filtering a large list down before sending the interesting items to a smarter model. The hosted cost for these tasks is small per call, but at volume, doing thousands of them a week, the local alternative becomes clearly worth the setup. Now I want to be honest about the trade-offs here. Running a local model has its own costs: the hardware, the electricity, the time to set it up and keep it working. It is not simply free. It is a different cost structure, one where you pay mostly upfront in hardware and effort rather than per call. Whether it makes sense depends entirely on your volume. If you do a few hundred calls a month, just pay the API. If you do tens of thousands, the math changes. I am not going to tell you which way to go on that. Run the numbers for your own situations. Set hard spend ceilings. The sixth tactic is one I wish I had set up on day one. Hard spend limits. Every provider I use offers some form of budget alert or hard cap. A hard cap means that when you hit the ceiling, calls start failing, rather than letting charges keep running. This sounds scary, but it is far less scary than waking up to a surprise bill after a runaway loop. I set monthly ceilings per project and per API key. I also set soft alerts at around 70% of the ceiling, so I get an early warning and can investigate before things stop working. The exact numbers depend on your project. The point is that you want a ceiling that represents the most you are willing to spend in a month, not your expected spend. Expected spend can drift, the ceiling does not. And knowing there is a hard limit below which no runaway bug can blow past is genuinely calming in a way that just trusting your code is not. Monitor your spend so it is never a surprise. Setting a ceiling is not enough on its own. You also need to look at spend data regularly enough to spot trends before they become problems. Every provider has a usage dashboard. I check mine at the same time each week as part of a short review I do on all my running pipelines. What I am looking for is not the absolute number so much as the shape. Is a particular project trending higher than last week? Is a new integration I shipped showing up as a spike? Did something I thought I turned off turn out still to be running? The dashboard answers these questions fast if you look at it. It almost never tells me something I urgently need to act on right this second, but the 2 or 3 times it has caught an actual problem, that 10-minute weekly check paid for itself many times over. The biggest waste I see: huge context on every call. If I had to name the single most common waste pattern in the setups I look at, it is this: sending a huge, growing context on every single call, even when most of it is irrelevant. I see it in conversational bots where the entire message history is appended on every turn. I see it in document processing pipelines, where the full original document gets stuffed into every step, even when later steps only need a small extract. I see it in agent loops, where all previous observations are carried forward even after they have served their purpose. The fix is almost always some version of the same thing. Figure out what the current step actually needs to know and send only that. It sounds obvious, and it is. But the easy thing to do when building fast is just to throw everything in and deal with it later. The cost of not dealing with it adds up fast. The second biggest waste: agents that loop without a stop. The second pattern I see most often is agent setups that have no reliable stop condition. An agent loop that can decide to take another step will, in many cases, keep taking steps longer than it needs to, because the marginal cost of one more step is not something the model itself is tracking. From the model's point of view, doing more work looks like thoroughness. From your billing dashboard, it looks like runaway spend. The fix is engineering, not prompting. Set a maximum step count. Make it a hard limit in code, not a soft suggestion in the prompt. Log every step so you can see exactly what the loop did. And if you can, design the task so the stop condition is obvious and checkable from outside the model, not just from within it. I now treat any agent loop without the hard-coded step limit as a latent billing risk, and I do not ship those without fixing it first. So that is the practical picture. Match model size to the actual task. Cap context ruthlessly. Cache the parts that do not change. Batch what can wait. Use a local model for cheap bulk work if the volume justifies it. Set hard spend ceilings. Monitor the dashboard regularly. And treat huge context and looping agents as the two biggest places to look first when something runs expensive. None of these are exotic techniques. They are just the habits I wish I had from the start, instead of learning them from a surprise bill. The goal is not to use AI as cheaply as possible. The goal is to understand where the money goes well enough that you are always choosing, never just discovering. If you want more honest, ground-level breakdowns of how I actually run AI in production, subscribe and follow along. Thanks for watching, and I will see you in the next one.